Okay, so here it's asking us to reflect this image across the y-axis. So again, we are reflecting across this axis here. And we know when we reflect, it's just we're taking a mirror image. We're taking this and we're flipping it over this y-axis. So we're going to be moving from this quadrant 4 into this quadrant 3. From quadrant 4 right into quadrant 3. And if we remember, the distance between the axis here, the x-axis and the y-axis, it's all going to stay the same. These lines, these points here, I'm going to go ahead and label my points, these endpoints here, and that way we can draw it properly. They're going to stay on line. They're still going to be 2 units away from the x-axis, and they're going to stay on this -2, y equals -2 line, as well as these points down here. They're going to stay on this y equals -8 line, and they're still going to be -8 spaces away from our x-axis. And if we remember, when we're reflecting across the y-axis, then our points, we go from an xy point to a negative x positive y. Okay, so let's go ahead and label these points. This is 4, -2. Okay, and I'll go ahead and put that here, 4, -2. We can label this A, B, C, and D. So this will be our A. And B, it looks like we're at 6, -2. And C is at 7, -8. And D is at 5, -8. So when we reflect, again, we're expecting it to be about the same distance. Not about, but exactly the same distance away. But we're just taking this image and flipping it over into our quadrant 3 rather than our quadrant 4. So let's see how it changes. If we are to take a -x and the same y, we would have a -4, -2, and then -6, -2, and then -7, -8, and -5, -8. And again, remember, whenever we are reflecting, we'll address this down here. Reflecting, rotating, translating, nothing happens to our image. Okay, our image remains the same in terms of dimensions. Nothing changes with the angles or the lines. The length of the sides all stays the same. So let's go ahead and see what we've got here. Now we have a -4, -2. So we're right here, and a -6, -2. And right here, which is what we were looking for, 2 units away from the x-axis. And then a -7, -7, -8. And a -5, -8. And you see that it's a mirror image now of our original, where A prime, B prime, and C prime, and D prime. And you see how when we flipped it, notice how this one is leaning in towards the origin, and this one should also be leaning in towards the origin. If we had translated it, if we had picked it up and just moved it over, then it would still be leaning towards the left. However, when we reflect it, we take it and we flip it over some rotation point, some reflection point, or this line of symmetry. We take it and we flip it, therefore it's going to be leaning in the opposite direction. So now we're leaning to the right. You see we have mirror images, and we can go ahead and answer these questions. When it's reflected, 2 sides are parallel to each other in the original figure, then those sides are parallel to each other in the final figure. That's true. We know nothing happens to the dimensions, okay? Final angle measures are smaller than the original. That's false. Nothing happens to these angles. These angles here, they're going to stay the same. All those angles are still going to measure the same. These are going to stay parallel, okay? These ones are equal to each other. These ones are equal to each other. And these are also going to be parallel. All of that stays the same when you pick it, when you reflect it about an axis. Nothing is distorted. We didn't shrink it, we didn't dilate it at all. So when the figure is reflected, its side lengths stay the same. That is true.